Next, we're going to go over rules and formulas. There's a total of, let's see here, there's a total of five rules and formulas, PowerPoints, and these are all on Google Classroom as well. We're going to go over rules and formulas one first. Um, a lot of this information is going to be covered in individual lessons as well. So some of this might be review for you, some of it might not be, but we're going to go over it fairly quickly, and probably in a little bit more detail with a lot of these different topics. So if some of it feels a little bit rushed to you, just know that these are going to be topics that we're going to cover a second time as well. So the first rule and formula part that I'd like to talk about is actually, let's look at the overview here. So slope, y-intercept, and standard form. These are all just common uh, ways that we can talk about the different parts of a function or a graph. Modify to solve, rule of three. Um, that's just changing equations to solve them properly. Horizontal and vertical lines on the graph, how those are graphed. Pretty straightforward and simple, especially since we've gone over Desmos. So you can graph a lot of this stuff on Desmos as well, if you're ever a little bit confused about what the question is asking. And then X and Y intercepts, where it crosses the X and Y axis. This is a little bit technical jargon with how we write standard form and slope and y-intercept. Slope-intercept form, though, is the form y equals mx plus b. If you can change the equation so it equals 1y or y, and the rest of everything else is on the other side of the equal sign, that's going to save you a lot of trouble. Sometimes our equations are written in standard form, like this, where we have something x plus something y equals a number. Here it's just telling us the shortcut for slope is equal to negative a over b. Let's take a look at why that is. So if we solve for what y is, this is if for standard form, we have ax plus by equals c. We'd subtract ax from both sides, get by equals negative ax plus c. We don't know if b is 1 or if it's 5 or if it's 10. So or if it's a fraction even. So we want to solve for 1y, so we're going to divide by b, and we divide by b, and we get y equals negative a over bx plus c over b. Because there's a plus here, we divide both of these by b, the a divided by b and the c divided by b. So now it says the slope is equal to negative a over b. This is our slope. It's the number next to the x. And that's the same thing as m right there. So that's how we find our slope algebraically with standard form. Now, slope is just rise over run, or change in y over change in x. And we write slope like m. We also have a formula for it. And you might remember this formula from previous math classes. That's how we find the slope with the formula. How much our y changes divided by how much our x changes. But this is all just uh, the algebraic reasoning behind it without numbers, and I always think this is much more difficult to learn when there's no numbers. Just know that slope is next to the x. We also write it in terms of m when we have it equal to 1y. Let's take a look at this. This tells us four options, all in standard form. And it says the line N is shown in the XY plane, or it's graphed. Which of the following is the equation of line N? Well, I would start by graph. You can either graph all four of these on Desmos, Or you could decide, okay, this is at 0, -2. So our B is equal to -2. Change that. B is equal to -2. Now we've got to figure out our slope. So to find the slope, we need to find 2 points that we know for sure that are on our line. So there's 5, 0. Now I'm just going to use the gray to trace it. So we're going to go up 2 plus 2. That's on the y. So our change in y equals +2. And then we're going to go over 5. So our change in x is equal to +5. Now our slope is equal to change in y over change in x. So that's 2 over 5. So that's what our slope is. B is -2. And if we write this in slope-intercept form, this is y equals 2/5 x minus 2, or plus -2. But now it wants it in standard form. So to write it in standard form, we could just solve it in standard form. So we could +2. Actually, we leave our whole number on this side. So we can multiply everything by 5 and multiply everything by 5. We get 5y equals 2x minus 10. Subtract 2x on both sides. And we get, let's see, we get -2x plus 5y equals -10. But none of those choices are on here. So we can multiply by -1 and by -1. And we get a final answer of +2x plus, or excuse me, minus 5y. And -1 goes to both of those. Equals 10. So our final answer is D. Now, there's a lot of different ways that you could have solved this. You can plug all those into Desmos. You can solve for what 1y is. If you're really good at doing y equals mx plus b, that shouldn't take you very much time. You can also plug in, let's see, we should be able to plug in the point that's x comma y. We should be able to plug this in to get a true statement. So let's do that for D just to check. So 2 times 5, 5 is our x right here, minus 5 times y is 0. That equals 10. 10 minus 0 equals 10, and we get 10 equals 10. And so that's how you could check your answer if you wanted to check your answer. You might not even have to do all of this algebra. If you plug in 5, 0, you could plug in 5, 0 for A, B, C, and D and see if that any of those give you a true or false statement. So there's many different ways to solve these problems. I just want to show you all the different ways that you can, so you can decide which way is the fastest for you. They used the solution for this one. They just said slope is -a over b, and that's how they solved it with this solution. Technically, that'd be the fastest way, but I really don't expect people to remember that slope is -a over b. I think that's really difficult to memorize. Modify and solve. So sometimes we want to eliminate a fraction. We can multiply both sides by the denominator of the fraction. We did that in the last problem. But let's look at an example. So here we have a system of equations. It says D is a constant, and if it has infinitely many solutions, what's the value of D? Infinitely many solutions means that the equations equal each other. So let's take a look at what we can do for this one. We don't know what D is. Um, so we've got to figure that part out. We can divide the first equation by 2 to simplify things a little bit. So if we go back up here, and if we divide this by 2, we get 2x minus 7y equals 18. That sort of helps us to get started. Then we can go to the second equation, multiply both sides by 10. And the reason that we'd want to do that for multiplying by 10 is because if we get rid of these fractions, that can be really helpful to get rid of fractions. So let me just write this here. So if we divide this by 2 on both sides, we get 2x minus 7y equals 18. And if we multiply by 10 on both sides, we get negative, let's see, if we multiply by 10, that's negative 10 over 5x plus 70 over 10y, multiplying by 10 or 10 over 1 equals 10d. So let's simplify equation 2. I like to call these equation 1 and equation 2. That helps me to keep track of everything. So when we write equation 2 again, we know which one we're looking at. So this is negative 2x plus 7y equals 10d. Okay, now the last thing we want to do is we want to make sure that if they're equal to each other, that means that they have infinitely many solutions. So let's make this so this negative 2x equals the 2x. So if we times by negative 1, negative 1 on both sides, and times by negative 1, then we get 2x minus 7y equals negative 10d. Now we can see that the 2x and the 7y, negative 7y, are the same. And if it has infinitely many solutions, that means that they're equal. That also means that we have a line that is the exact same line as the original, because the amount of solutions is where it crosses. So we imagine that we have this is line number 1 on our graph, and this is line number 2 on our graph. And when we look at systems of equations, we want to know, where did they cross? Did they never cross? That's no solutions. Do they cross once? That's one solution. Or do they cross infinitely many times? And this is infinite solutions. So infinite solutions means it's the same line. So to make this, so here's our two equations we have now. Here's equation 1. Here's equation 2. To make equation 1 equal equation 2, we now have to set, we have the x's are the same, the y's are the same, the equals in the same spot. Now this is 18 equals negative 10d. We're going to solve for d here. And we get negative 18 over 10 is equal to d. And if we simplify that, that's negative 9 over 5 is equal to d. So that would be answer choice B. And we're gonna learn about linear functions and systems of equations, as well as systems of equations with quadratics, I believe, on our last day of class as well. So this is just an overview of systems of equations, as well as how to use algebraic principles to find the answer of a missing value when they give us a third letter or third variable. So this is no solutions. The lines never cross. This one is one solution. They cross just one time there. And infinite solutions, they're crossing infinitely many times. This line goes on for infinity, and so does the green one. So they're just crossing constantly. They're the same exact line. Okay. The rule of three, when we have three values in a problem, we can find the fourth value by setting up a proportion and doing cross multiplication. This is a really important rule to know. So a lot of these are in word problems. So they give us three amounts and then they ask us to figure out the fourth amount. Automatically, you might be really good at reading these after a while, but automatically, I didn't even read this problem yet, and my brain already thinks in terms of rule of three or proportions. So the rule of a proportion is if we match the symbols, we can say like x over y is equal to x over y. So this one's talking about a turbine that generates 100 kilowatt hours of electricity every six days. How long would it take the turbine to generate 150,000 kilowatt hours of electricity? So 100,000 kilowatt hours every 6 days. We're just going to write a proportion. 100,000 kilowatt hours for every 6 days is equal to 150,000 kilowatt hours over X days. Now, we don't really even have to have these here now that we've matched them up properly. But you have to match them up properly. If you switch them, if you put kilowatt hours on the top over on the left side and then on the bottom on the right side, it's not going to work. So now after we cross all that stuff out, I'm just going to erase it. Now we just have numbers to deal with. And this is very simple cross multiplication. When you have an equal sign, you do cross multiplication like this. If you have a times, you multiply it cross like that if it's times. But this is equals, so we're going to do cross multiplication. This is 100,000x equals 6 times 150,000. 6 times 150,000. That is 900,000. Divide by 100,000 on both sides. And we get x equals 9 days. So in 9 days, they can produce 150,000 kilowatt hours of electricity. Okay, so that's proportions. And if you need to see the solution, again, this is on Google Classroom, and this is worksheet number 02, rules and formulas. Horizontal and vertical lines, these are pretty self-explanatory. If we get something like in the form y equals mx plus b, but if there's no m, if m is 0, then we get y equals 0x plus b, and then we just get y equals b. Here they said y equals c, but they just use a different letter. Basically, b is just a whole number. So if this was y equals 5, this would be 5 on the y-axis, and our y goes horizontal. Seems a little backwards to students sometimes because they're like, well, our x goes horizontal. Why is it? If it helps you to remember that it's the opposite of what it's parallel to, then that can help you. But really just go up to 5 on the y, and then you're going to draw a line that goes through the 5. For x, if we said x equals 5, you go to 5 on the x, draw a straight line. That's all that is for vertical horizontal lines. The quadrants are important to know. Quadrants of the graph 1, 2, 3, 4. So it goes in a circle, starts in the upper right, and then it goes counterclockwise, the opposite way that a clock would tick. So here it doesn't tell us the graph of the line. It says it's completely contained in the quadrants 3 and 4. So it says all of our graph is here and here. So it says what could be the equation? Okay, let's take a look at this. If we say x is -3, here's -3. Let's just say that's -3. If x is -3, that's our line, and we go through 2 and 3. Can't be that one. And you can graph these on Desmos if you need some assistance, if you maybe forget which way the lines go. Y equals -3. We can say -3 is down here. Our Y line go like that, goes through 3 and 4. Looks like that one's B. If we did 3x, that's going to be going through 0, 0. It's going to go up 3 over 1, up 3 over 1. And I'm just estimating what it would look like. It's also going to go down 3, back 1, down 3, back 1. So that one would go through 3 and 1, so it can't be C. And then -3x is going to be the other way around. I'm going to start at 0, 0. I'm going to go down 3 over 1, down 3 over 1, up 3, back 1, up 3, back 1. So that one goes through 2 and 4. That one's not right either. Okay. That was the answer there. The x and the y intercepts. Okay. To find the x-intercept, that is where it crosses on the x-axis. Let me see if there's an example for this one. Yes. Okay. So the x-intercepts for this graph are here, here, and here. And we can say them as a point, or we can say them at what x equals, and we can write them like a set. So we can say this is -3, 1, and 6. So those are our three answers for x, or you can say -3, 0, 1, 0, 6, 0. This one says, which of the following values of x is y equals 0? Okay, this one's a little interesting how they phrase it. I'm going to go down to our solution here. And that really just means our x-intercepts. So when y equals 0, here's our y, here's x. When y equals 0, we're just looking at this line, y. And so 0, we mark it like that. And when y equals 0, that's our line, which is the x-axis. So it's basically saying, where does it cross the x-axis? So that's another way that we can say f of x equals 0. And so it says, from these values, where does it cross? So -6, no. 0, no. 1, yes. 3, no. So for our x and our y-intercepts, they are switched. So to find the x-intercepts, these values, we set y equal to 0. I'm just going to abbreviate this. X-intercepts equals y. I'll just say x-intercepts mean that y equals 0. Our y-intercepts mean that x equals 0. That's what we're setting those values equal to. So our x-intercepts are along the x-axis, points where it crosses. Our y-intercept for this one is here. And our y-intercept is 0, 3. Or it might just say 3 if it gave you multiple choice. Okay, so if those are tough, you can always just write this function. Yeah, actually, no, it doesn't give us the function. It just gives us the graph. So you don't have to graph this. It already graphs it for you, and you just have to know what it means. F of x equals 0. That means the x-intercepts there. All right, so I believe that is everything for rules and formulas part 1.